Hey guys, Charles here. Let's do 2024. This is set one. Oops. This is set one for micro 2024, number one, set one. Soja's Farm is a typical profit maximizing firm that produces and sells soybeans in a constant cost industry, and it is perfectly competitive and it is in long run equilibrium. That's a lot of information, but we need all of that. So let's make sure the price is 14. They want us to draw a side-by-side graph for the soybean and for this is the market and this is the firm, obviously, and show each of the following. The price and quantity, 14 QM, profit maximizing price and quantity, PF and QF for Soja or the firm, and the firm's ATC, what it looks like in long run equilibrium. So this is all pretty standard for just about any perfect comp question. So price and quantity, we'll fill those in first. We also know we have the market, and then we have the firm. We know our market is just supply upward sloping and demand downward sloping, and we know we have Mr. DARP. Now you could just draw it all through there. So that was not quite on target, but let's put it right there just to be pedantic. That is our Mr. DARP curve. Now, I don't know if your teacher calls it Mr. DARP, but this is marginal revenue, demand, average revenue, and price. Every so often, they're going to ask you to draw the average revenue curve. If you just know that you just always plug Mr. DARP in, you're pretty golden there. Anyway, I would just do it every time. This is marginal cost, and then we needed to put our average total cost just banging right through that lowest point right there for ATC would be right on that profit max point. Looks like we have QM here. We're going to do $14 there. QF and PF, so this is our price for the firm. This is the quantity for the firm. Let's get this little piece of something out of the way there. Now, ATC, let's label that. Label. So done. I like it. With long run equilibrium, again, long run equilibrium implies that the ATC is at its lowest point right there at that profit max point. We've got PF, we've got QF. That is the profit. We've got $14 and we've got QM all labeled. Tick, tick, tick. We're all good. Let's run away from that. If Soja's Farm is the only firm in the market that chooses to increase its price to $15, will Soja's Farm's total revenue increase by 1, remain the same, or decrease by 0? Decrease to 0. Well, first of all, what we should know about perfectly competitive firms is they have no price making power at all. They are what we call price takers. So since they have no price making power at all, and there are literally, let's say, thousands of these firms all producing the exact same good at $14, if old Soja Farms decides to increase their price to 15, they're going to find no customers whatsoever. So as they raise their price to 15, they will lose all of their customers, which will cause their total revenue to go down to 0. And we would want to make sure that we explain it that it decreased to 0. So price takers is the important part here. Obviously, no price making power. You could have said that. You could have said that the firm's price is always the same as the market. And then if one firm tries to raise its price, well, just think about that. You could simply walk next door and buy soybeans at $14. Why would you ever go to a $15 shop? Easy enough. Lose all their customers down to total revenue is 0. Let's look at C. Soybeans are used as an input in the production of tofu. Tofu now becomes more popular. On your graph in A, show the effect of an increase. This is just a demand determinant. People's taste and preferences become more for soy or tofu. Therefore, demand for soybean is going to increase. We want to show our new price, market price, and the new quantity for the firm. So let's go back up here. Oops. What we recognize is the demand for tofu is going up, so the demand for soybeans is also going to go up. This is going to give us, let's see, maybe we could pick another color here just to be fancy. This is going to give us a brand new Mr. Ooh, I don't like that at all. Let's back up here. Let's see if we can draw that in a little bit easier here. Something like that. It's still pretty bad, but that's okay. We got a new Mr. DARP. Easy enough. We'll call that Mr. DARP 1. That's Mr. DARP 2. We recognize that due to demand going up, we've got our arrows here, that the price is going to go up too. That's what they wanted us to call this PM2 probably. Here's our QM2. We know that the firm is now still going to produce at profit max, where price equals marginal cost, or we could say where marginal revenue equals marginal cost. That's a better way to say it. We'll call that Q star. I want to go one step further and show this firm. Its firm is now, before it was breaking even in long run equilibrium. Now it's actually making profits. If we had to show profits, we'd go right here where that quantity hits that ATC and bounce to the left. All of this rectangle in here would be profits, right? So this is the price they can charge for the good, whatever that is. This is the cost of producing that good. So all of that up above the cost would be profits. I hope that makes sense. All right. Q star, we got it. P star, Q2, Q2, P2. I think we're good. P2, Q2. You don't need the M, but we're cool. Given the increase in the popularity of tofu, what will happen in the number of firms in the soybean market in the long run? So I'm going to show it again to you because I think this is where the important part of constant return, or sorry, not constant returns, constant cost. They did say constant cost. Yeah, yep. All right. Where constant cost, did I read that? What's wrong with me? Constant cost industry. All right. At a constant cost industry only affects how far your supply curve will shift. I say only, but for our understanding, that's what has to happen. Here's Mr. DARP again. Remember, marginal revenue, demand, average revenue, and price. We got marginal cost curve. We've got our profit max, where marginal revenue and marginal cost come together. Let's call that QF. Here's Q. Don't forget your P's and Q's. They'll take a point. This is PM. This is QM. We're all set up. ATC needs to be right through profit max there, and we're all set up in long run equilibrium. What we know above happened was the demand for this goes up. This causes us to have a new Mr. DARP. I'm getting to the point where what it means to be constant cost. Here we are with our new quantity. As the price goes up, the firm produces more, as does the market, QM 1, 2, right? And we know they're making profits right there. We can see that. The question is, when there's in the short run, we know there's profits. And then their question is, what will happen to the number of firms in the long run? Well, in the short run, we have profits. Therefore, firms will enter chasing after those profits. As firms enter, well, we have more firms. Now, they didn't ask specifically about what would happen to the price, and that's where that constant cost industry understanding. As firms enter, they're going to produce more of this good. That supply curve will shift, and it will shift the price back to the original price. That's what it means to have constant cost, is the price will return to the original price. So we know exactly how far supply would shift. Supply would shift right through there. Let's call that 1 and 2. It shifts to the right. It drives the price back down. The firm is going to make more because there's more firms producing this, so the market has more of this good being produced. Obviously, when the price goes back down, the firm would return back to making QF. So this is our sort of long run. Here's our us at equilibrium. We go into the short run, prices are high, and then in the long run, firms enter due to profits and push those prices back to that original price. All right, boy, that's a lot of words just to explain that understanding right there. Little elasticity here. Let's see. Suppose a 25% increase in the price of quinoa. I don't know. I've probably never eaten it in my life. Decrease in the quantity demanded of quinoa and a 10% increase in the quantity demanded for tofu. Is the demand for quinoa elastic, inelastic, or unitelastic? Well, I know this immediately because they want you to use numbers, but the price increased by 25%, and the quantity demanded for the good went down by 5%. So the price increase was greater than the quantity demand increase or the demand increase. Therefore, we know it's inelastic. Now, they want us to use some math. That's cool. We just have to find PED. We know PED is a percentage change in quantity demand over percentage change in price. We plug in our numbers, 25 and 5, and I think that's going to give us 0.2 and this is obviously let me say it again. I haven't done this one in a while. I haven't done any elasticity since before the summer, so it's got to get back into my brain. If we're anything greater than 1 is elastic. Anything between 0 is 1 is inelastic. Obviously, if your PED value would have been 1, it would have been unit elastic. If your PED value was 0, it would have been perfectly inelastic. And if it had been infinity, that would be perfectly elastic. We don't see that very often, if ever. So this is obviously between 0 and 1, definitely inelastic. And they just want the formula, and they want your number there. Cool. Calculate the cross-price elasticity between quinoa and tofu. So cross-price elasticity, what we could also call XCD, this is cross-price. And it is the same formula, percentage change in quantity demand over percentage change in price. But recognize XCD, cross-price, two different goods, good A and good B. Recognize that good B here was the price increase. So we could have called it Q for quinoa, whatever. And then we could have done a percentage change in quantity demand for tofu was 10%, right? So 10 over 25.25, easy enough. It is positive. That we have to know whether it's positive or negative. And for XCD, it does make a difference. Let's make sure we've got the price going up, but we also have the quantity demand going up, going in the same direction, gives us a positive number. Positive number means that these two goods must be substitutes. They don't really ask that, doesn't matter. We're all working on that number right there, 0.25. It's also between 0 and 1. So not only are they substitutes, they're also inelastic. It is an inelastic good in relationship to one another. I think that's okay. We're cool. All right. Any questions? Just send me a quick email. All right. Keep working hard. You're doing great. Or comment. Thanks, buddy. Bye.